Today we'll be discussing factoring polynomials. So this is the recorded version of this lesson for you to have a reference for your quiz or for your exam for this first quarter. So again, I will be discussing to you factoring polynomials. So our agenda for today is to review their polynomials and special products, and to factor completely different types of polynomials, specifically common monomial factors. So we will be talking about these two particular agenda for today. So brief introduction for factoring. We will be dealing with these questions. What does factoring mean and how to do factoring? So now we will just be reviewing some of the terms that we have already encountered last year. So we have here understanding factoring. On your screen, you can see the word factoring, and the word factor there is highlighted. Why? Because factoring is somehow related to multiplication of polynomial, and factor is a common term which connotes the operation multiplication. So how does that relate to multiplication? Let's see. So what does factoring mean? It means regrouping, rewriting, reforming. So what does that mean? We are going to regroup, we're going to rewrite, and we're going to reform a certain polynomial into its other form. It says here that it's the reverse process of multiplying. Why did we say so? So later on we will see. And it is expressing a polynomial into its prime factors. So we are going to remake or to regroup a polynomial into its other form. That means we are going to make this into its factored form. So how do we factor? We have different types of factoring techniques that we'll be having. Common monomial factor, which will be discussed in this video. Difference of two squares, perfect square trinomials, quadratic trinomial, and sum or difference of two cubes rather. So where do we encounter factoring? We will be talking about factoring for a lot of times, but how will we try, or where do we encounter factoring in our common activities? So common applications include dividing something into equal pieces. Example, exchanging money, comparing prices, understanding time, and making calculations during travel. So those are the common applications of factoring. How do you do factoring in real life? Let's say, for example, exchanging money. When we try to exchange money, there are formulas in the foreign exchange that actually makes use the concept of factoring. So later on, we'll know or we'll see some applications of those things. So let's get started. Let's have a review on multiplication of polynomials. I have here the polynomial 5 multiplied to m minus n. 7a raised to 3 multiplied to 1 minus 2a plus 5a squared. Now, on this one, we're trying to multiply 5 to m minus n. So what we did here is to distribute 5 to m minus n. So what we did is distribution. So we distribute 5 to all of the terms inside the parentheses, on this case m minus n. That's why we have 5m minus 5n. On the other hand, we have 7a raised to 3 multiplied to 1 minus 2a plus 5a squared. The same process, we're going to distribute 7a raised to 3 to all of the terms of the polynomial inside the parentheses to arrive at this particular answer. Now, what we did here, 7a raised to 3 multiplied to 1, that is 7a raised to 3. 7a raised to 3 multiplied to negative 2a, that would be negative 14a raised to 4. You can observe here that we added the exponent, so that is a rule that when you multiply polynomials of the same base, you're going to add its exponent. So the same process happened on the last term. We added the exponent. Moving on, we have this first factoring technique to discuss, common monomial factoring by GCF. So from the term itself, common monomial factoring, that means we will be involved with monomials as well as with GCF. So it involves moving out the greatest monomial factor that the polynomial have in common. So just like what we have talked about a while back, sabi natin that factoring is regrouping, a way of regrouping the polynomial. So on this particular factoring technique, we are going to move out GCF or GMF, greatest monomial factors, that your polynomial have in common. So all factors that are common to the terms of the polynomial will be moved out in such a way that you will be obtaining a monomial factor. How to factor? We have here the steps. Get the GCF of the constant and of the variables of each term of the polynomial, and then divide each term by the GCF to get the other factor. So these are the two steps that we'll be having for this particular factoring technique. So let's have some examples. This is the same example as a while ago. So we have here 5m minus 5n. So just like the steps have advocated a while ago, sabi niya, we will move out the GCF of the constant first. So your constants here are 5 and negative 5, and then if you have something in common still with the variables, you're still going to move them out. On this case, m and n are not common, so we'll not be moving out any common from the variables. So we have here 5m minus 5n. Let me just rewrite that one. 5m minus 5n. So you can see here, we have common factor. The greatest common factor for 5 and negative 5 would be positive 5. So that means we're going to move out 5 positive, but we can also move negative 5, by the way. So 5 positive, we move that out, and then we divide each term by 5. Divide each term by 5. And then you just simplify this one. 5 will be cancelled, so you'll have m. This one, 5 will be cancelled as well, minus n. So this will be now your final answer. Okay, the other one, we have the given 7a raised to 3 minus 14a raised to 4 plus 35a raised to 5. So how do we do that? The same process as we did with the other example a while ago. So we have here 7, negative 14, and 35. Their greatest common factor would be 7. So we'll move out 7 for their constants. A raised to 3, a raised to 4, a raised to 5. Their greatest common factor would be a raised to 3. Now, you can observe here, when we have terms of the same exponent and of the same base, we're going to consider the term with the least exponent as its GCF, because you can still divide a raised to 4 by a raised to 3. You can also divide a raised to 5 by a raised to 3. That's why a raised to 3 will be your greatest common factor for the variables with the exponents. We moved out 7a raised to 3. That means we're going to divide each term of the polynomial by 7a raised to 3 as well. So this one, 14a raised to 4 divided by 7a raised to 3 plus 35a raised to 5 divided by 7a raised to 3. And then we're going to simplify this further by dividing all of the terms that we have inside the parentheses. We will just rewrite 7a raised to 3. This one would be 1 since they are the same. The numerator and the denominator are the same, so you'll be left with 1. 14 divided by 7, that would be 2. A raised to 4 divided by a raised to 3, that would be a. What we did here is we subtract the exponents, since it's a rule that when we divide, we subtract exponents. Plus, what? 35 divided by 7, that would be 5. A raised to 5 divided by a raised to 3. Since we're going to subtract the exponent, we'll be left with a raised to 2. So this will be your final answer for that one. Another example, we have here negative 4e raised to 2 plus 7e raised to 3 minus 9e raised to 4. Now, you can observe here we have negative 4, 7, and negative 9. So those terms are not, or those constants doesn't have any common factor together except for 1. So we won't be able to move out any common factor for negative 4, 7, and negative 9 except for 1. So we won't be moving out any common factor for negative 4, 7, and negative 9, since if we move out 1, that would still be negative 4, 7, and negative 9 inside the parentheses. So it's like moving out nothing. So e raised to 2, e raised to 3, e raised to 4. Just like what we said earlier, we're going to consider the variable with the least exponent. So we'll move out e raised to 2 or e squared. So the same process, we will divide all of the terms by the common factor given. E squared minus 9 e raised to 4 divided by e squared. So simplifying this, we'll have cancel. This would be negative 4 plus this would be 7e, since 3 minus 2 would be 1, and we don't usually write 1 as an exponent, minus 9e squared. So this will be your final answer. The other one, 7a raised to 3 minus 14a raised to 4 plus 35a raised to 5. Now, I think this one is repeated, so we can skip this one. We have already solved that a while ago on this item. Next, this one, 32e squared f raised to 3 plus 64e raised to 4 f raised to 8 minus 16e raised to 4 f raised to 4. You can observe here we have 32, 64, and negative 16. So their greatest common factor would be 16. We have e squared, e raised to 4, e raised to 4. So we'll move out e squared, f raised to 3, f raised to 8, f raised to 4. So we'll be moving out f raised to 3 since again we are considering the variable with the least exponent. So this will be your common monomial factor, and we will divide each term of the given polynomial by that monomial. So we'll divide it by 16e squared f raised to 3. The other one, 64e raised to 4 f raised to 8 divided by 16e squared f raised to 3. The other one, 16e raised to 4 f raised to 4 divided by 16e squared f raised to 3. So simplifying this further, we'll have 16e squared f raised to 3. 32 divided by 16 is 2. E squared f raised to 3, this 2 will be cancelled. So we'll be left with 2 only for the first term. 64 divided by 16, that's 4. E raised to 4 divided by e squared, that would be e squared. F raised to 8 divided by f raised to 3, that would be f raised to 5. The other one, 16 divided by 16, so we'll have negative 1 since we have a negative sign there. E raised to 4 divided by e squared, will be left with e squared. F raised to 4 divided by f raised to 3 will be left with f. So this one will be your final answer for this polynomial. Now, we have here a problem to solve. Your room has a total area of 56x raised to 3y squared plus 28xy raised to 5 minus 16x squared y raised to 4 square meters. Find the dimension of your rooms. Now, one way of finding the dimension of the room is to factor out this polynomial given by GCF method, or by common monomial factoring by GCF. So, assuming we have this room, for example, the area is this one. The area is the measurement inside the rectangular or inside the room. So we will be finding out the length and the width of the particular room. And that means we're going to factor 56x raised to 3 y squared plus 28x y raised to 5 minus 16x squared y raised to 4. So we have 56, 28, and negative 16. Their common factor would be 4. So we will move out 4. X raised to 3, x squared. So we'll be moving out x. Y squared, y raised to 5, y raised to 4. So we'll be moving out y squared. And then we just have to divide each term. So we have here 56x raised to 3y squared divided by 4xy squared plus 28xy raised to 5 divided by 4xy squared. Then the last one, 16x squared y raised to 4 divided by 4xy squared. So simplifying this further, we'll be left with 4xy squared. 56 divided by 4, this would be what? 14, right? 14x squared y, I'm sorry, we have here y squared, so we should not include y anymore. So let me just erase. So we'll be left with 14x squared on the first term plus, this is 7, x will be cancelled, y raised to 3. On the other hand, we have negative 4 x y squared. So this will be your dimensions. That means the dimension of the room is 4xy squared meters by what? 14x squared plus 7y raised to 3 minus 4xy squared meters. So this will be your final answer.